Hi students, now we'll talk about section 3.4, which is a circular motion. For example, we have almost the moon rotating around the earth because we have for this system attractive force, which is the gravity, which attract moon to earth and earth to moon. And the motion of the moon is a circular, and the velocity of the moon is tangential to that circular track. For example, to understand this, if we have a moving body in a circular motion and the radius of this circular track is r, maybe it be r small or r capital. If we have now two velocities, v0 and v1, but the speed is the same. What is the difference between velocity and speed? The speed is the magnitude of that velocity. It is the same. Maybe it is 10 here and 10 here, 5 here and 5 here, but the velocity is different because the direction of this speed is different than the direction of this speed, because we are talking about the velocity, which is a vector. What if we need to find the change in velocity? We have, this is the initial velocity and this is the second after a period of time, and the change in angle from the first point and the final point is delta theta. The total angle is 360, as we know. What is the change in velocity? It is v1 minus v0, or v final minus v initial. This is the vector of change in velocity. Look now between the change in velocity between the initial and the final point and the direction of that change in velocity. If we make that period of time shorter, then we take another points between v1 and v2, for example, with smaller theta, and we will see that the difference in velocity is changing the direction, because we have now two velocities and we converges them to other. This is the third one. What if we have, for example, a velocity and we take dt net, not delta t, we have d theta, or also we have dt after a short time, then the two vectors v1 and v2 will be almost the same, and the direction of the change in velocity will direct to the center of that circle. Look here, we have v1 in red, v2 in purple, and when they come to be at the same point, almost beginning point, then the direction of the change in velocity will direct to the center of rotation. Okay, this is just to understand why is the next concepts will appear like it is. During delta time, or dt goes to 0, we have dv, change in velocity, and this dv will point to the center. If we have change in velocity and we have change in time, then we have acceleration. The acceleration will be a vector, and this vector direct to the same direction of dv. In this case, dv is a vector and a is a vector. dv direct to the center of rotation, also the acceleration direct to the center of rotation. This acceleration to the center of rotation called a centripetal or a radial. So when the moon rotates around the earth, there is an acceleration toward the center of rotation. This acceleration a radian is equal to, we can derive this formula, but it is easy. It is equal to v squared over r. You can see that in paper page 82. V squared over r. V is the velocity that the body moving around the center of rotation over the radius. We are dealing with constant speed but changing velocity. If the velocity is changing in its magnitude, which is a speed, or in its direction, then we have acceleration. Now the speed is the same, but the direction of the velocity will changing, and for that we have acceleration. Because the speed is the same around this circle, then we call this motion uniform circular motion. Uniform circular motion, because we have non-uniform circular motion when the speed is changing. Okay? For constant speed we have uniform motion. Now again, the circumference of the circle or the track is 2 pi r. The time period to rotate a total rotation is t capital, which is period. We call t capital period. Period of rotation. So the velocity which is changing, or the speed which is constant, the speed which is constant is equal to the distance divided over the time. We know this formula. The distance is s, which is 2 pi r. The time is the total period, which is t capital. If we square it and use if we square the velocity, it will be 2 pi, it will be 4 pi squared, r squared over t squared. Now, the radial acceleration, what we found from before, which is v squared over r, we now know v squared in terms of t and r. We can use this formula and put it in the place of v. Then we have another formula for a radian in terms of the radius of rotation and the time period. Okay? We can compute, in this case, t from the acceleration and r. We have two formulas. Both of them are the same because we just use geometry, which is 2 pi r is equal to the total distance for this track, divided it for t to be the speed. For example, for the moon and the earth system, if the time period for the moon to rotate around the world, around the earth, is 27.5 days, which is the astronomical period, not the earth period. The earth period is 29.5. Okay, this is the t capital, which is the total period, and the radius in the average is equal to 385,000 kilometers. Can we find the acceleration between the earth and the moon? And we can also find the speed of the moon rotation. Now the time, which is 27.5 days, I convert it to seconds, which is 2,376,000 seconds. I write it also here in scientific notation. I use E, which is equal to 10 multiply to 10 to 6. Okay. Also the radius, I write it in the scientific notation, which is 3.85 multiplied by 10 to 8 meters. By using this relation, 4 pi squared is known. R, this is R. T squared, this is T. I need to square it. Then the acceleration toward the center of rotation, which is Earth, is 0.00269 meters per squared seconds, which means this is about 2 millimeters. Yes, it is 2 millimeters. It is just at the width the same as pin width, pinhead width. It's almost 2 millimeters or less. This is the acceleration for the moon toward the earth. Means that every second the moon be closer to earth at this distance, by this distance. What is the velocity, or I'm sorry, about what is the speed for the moon rotating around the earth? The speed is equal to 2 by r over t capital, which is the period. It will be approximately 1018 meters per second, which is equal to approximately to 600 not 600 0.6 mile 0.632 miles per second, less than a mile per second. This is the speed of the moon. Okay, now what is the non-uniform circular motion? When we have change in the speed, then we have non-uniform circular motion. If we have initially v1 and then we have v2, which is another speed, maybe it is more or less than v1. V, which is the speed, is not constant. We have another acceleration now. This acceleration, we can call it tangential acceleration, which is the same acceleration that we know from before, change in speed. The acceleration in tangential is different than the radial acceleration toward the center. The tangential acceleration is tangential to the circular track. Okay, now if we look, we have radial acceleration and tangential acceleration. In this case, we have two accelerations and the angle between them is 90. This is the angle between them. This is the angle. They are normal to each other. So we can find a resultant acceleration between them. Using the Pythagorean theorem, the magnitude of the new acceleration or the resultant acceleration, which is A, is equal to square root of AR squared plus AT squared. AR, A radial, and AT, A tangential. Look, this is A radial, this is A tangential. They are right angle triangle. What is the angle theta? What is the direction of that acceleration? If I need to find the angle from the tangential direction, which is theta, or from radial direction, which is phi, I can use tan inverse. tan theta is equal to this side, which is AR over A tangential. So theta is equal to tan inverse to AR or A radial over A tangential. If I need to find phi from the radius, is equal to tan inverse to A tangential over A radius. In our first example, which is Moon Earth system, if the moon changes its speed with acceleration 2 meters per second squared, just the moon be faster, and that's happened. It's natural. Find the resultant acceleration and its direction. We found from before that the A radial is equal to 0.0027 approximately meter per square second, and this is the A tangential. We just need to use the Pythagorean theorem. A is equal to the root of the square of the two accelerations. This will be equal to 0.5018 and something meters per square second. It is near to the A tangential because A tangential way more than A radius. We have a resultant, but it is almost equal to the A tangential, if you see that, because this A radial is small. What is the theta? This is theta. It is tan inverse to A radial over A tangential, which is equal to 0.077 degrees. If we need to find phi, it is the rest angle, which is 87. No, it is not 87. It is almost the rest angle, which is shift tan inverse. I will find it to 2 over 0.27. It is 89. There is a typo. 89, not 87, because when we need to add them together, this theta and this phi, the resultant should be equal to 90. This is the circular motion. We have the most formulas. A radial is equal to V square over R. Also the velocity, we can find it using 2 pi R over T. And we will solve another examples. Thank you.